Hi everybody, welcome to this next video. So in this one we're going to be looking at solving quadratic inequalities. If you are not 100% sure on how to sketch quadratic graphs, I suggest you go back and watch that video, which I'll put a link to as well that you can go back to, just to make sure you're happy with the concept of sketching. And also, if you're not 100% sure on factorising and solving quadratics, I suggest you go back and watch the video on that as well, when x squared is 1, but also when x squared is greater than 1. And then make sure you're happy with those two before you then watch this one. Okay, so let's jump straight in now and have a look at what we're going to be doing. So the first thing we're going to do is actually factorise this. Because it says solve and this is a quadratic, the first thing we're going to do is attempt to solve it, and we could either complete the square, we could factorise, or we could use a quadratic formula. But the first thing I'm going to do is look to see if this does factorise. So I'm looking for two numbers that add to give me 6 and multiply here to give me 8. So hopefully you can figure out that two numbers will be x plus 4 and x plus 2. Now technically, if we just go through the solving process, so x plus 4 is equal to 0, or x plus 2 is equal to 0. So in this case, x is equal to minus 4, or x is equal to minus 2. So your first thing to do in these instances is to solve the quadratic first. Now remembering, and as I say, this is why you need to make sure that you understand the concept of sketching, remembering that these two parts give me the root. So what I can do is, on this graph on the right hand side, I can actually go to these 2 points, so minus 2 and minus 4 become my roots, and I can plot those 2 points. Okay, now the next thing I know is it crosses at 8 on the y-intercept, so I can plot that point as well. If we go 1, 2, 3, 4, 5, 6, 7, 8, 8 is up there on the y-axis, so they are my 3 points I've already got. And now the last thing I want to do, if I want to sketch it completely accurately, is I need to find the turning point. Now, you don't have to fully accurately sketch this. You could just, using the information we've got, we could just work out where the rest of the points go approximately. But let's just go through that to remind ourselves on how we do that. This is by completing the square. So you half your b values, it becomes x plus 3 all squared. Then square that number, turn it negative and put it on the outside of the brackets, and then bring down the c value. Again, if you're not sure on how to complete the square, go back and watch the video I've done on that, which I'll put a link to as well. This then becomes x plus 3 all squared minus 9 plus 8 is minus 1. And then what you do to find the turning point is you flip this sign, so it becomes minus 3, and this stays as that. So my turning point is minus 3 minus 1, which is down there. Now, if I was to actually create a mirror line, so if I drew a mirror line down here, this point up here would actually be the same distance away in the other direction. So 1, 2, 3 squares away, 1, 2, 3, and that point would be just there as well. So sketching this quadratic graph would look like this. It doesn't have to be perfect, but it's going to help me to solve my inequality. So the first thing to do is to solve it. The second thing to do is to then sketch it. What we now need to do is you now need to figure out what our notation will look like. When you are solving a quadratic, your notation is going to look like this. It's either going to be x is greater than or equal to, or less than or equal to. So it'll either be this sign, or it will be this sign, or it could be that sign or that sign, depending on what the question's saying. So in this case, it's going to be greater than, we'll have a number, or x is less than a number. Or what it could also be written as is a number is less than x, which is less than another number. And so what we need to now determine is whether or not we're going to write it in this way, or we're going to write it in this way. Okay, and here's quite a quick way to do this. You basically choose the origin. So select this point here, which the coordinates of this point are 0, 0. What we're then going to do is we're going to substitute the x value into this initial equation that we've got up here. So I'm going to substitute 0 into there. So what I'm saying is 0 squared plus 6 times 0 plus 8 is greater than 0. Well, that gives me 0. So therefore, I'm saying 8 is greater than 0. Now, is 8 greater than 0? Yes, that is true. So because that statement is true, this point I've just selected here needs to be shaded. So I will shade this point. Now, because that point falls outside of the parabola, outside of the curve, I shade outside the curve. If you are shading outside the curve, you then end up using this notation. If you end up shading inside the curve, and I'll show you what that looks like in a little bit, you will end up using this second notation. But let's just use that information now. So I'll recap what I've just done. I've chosen 0, 0, that origin point there. X is 0, so I substitute 0 into x. So 0 squared is 0, plus 6 times 0, which is 0, plus 8 is 8. Is 8 greater than 0? Yes. So because that is true, I must shade this point. And I shade outside the parabola. What I'm now saying is x has to be greater than this point here, because it's that side of that point. So that point I know is minus 2. But it also needs to be this side of this line as well, which means it's going to be x is less than minus 4. Now, the reason that I'm saying that is because if I was to then, let's reshade, but we're going to just reshade this part here. If I was to substitute these values in, so x is greater than minus 2, so it can't be minus 2. The closest number it could be is minus 1. If I then take minus 1 and substitute it into the equation, what we end up having is 1 plus minus 6 plus 8, and that should be greater than 0. Well, 1 plus minus 6 is minus 7. Minus 7 plus 8 is greater than 0, because minus 7 plus 8 is 1, and 1 is greater than 0. So when I substitute in the first value it could possibly be from here, remember it's saying x is greater than minus 2, and because it's got to be greater than minus 2, it has to be minus 1. That's my first value I could use, so I've substituted that in there to check that works. Now, let's try it with the other answer I've got here. So I'm saying x is less than minus 4. So it can't be minus 4, which means it has to be minus 5. So I substitute in minus 5, so minus 5 squared plus 6 times minus 5 plus 8 is greater than 0. Well, let's double check that. Minus 5 squared is 25, and then 6 times minus 5 is minus 30, plus 8 is greater than 0. Well, 25 minus 30 is minus 5. Minus 5 plus 8 gives me 3, which is greater than 0. So that works for that as well. If I was to then choose any other number, if I was actually to choose minus 4 or I was to choose minus 2, then it wouldn't work. So that's how you can check that your answer is correct. So my answer for this, and the way I would note it down and how I'd finally write it, is I would then say x is greater than minus 2 or x is less than minus 4. Okay, because I've shaded outside the parabola, that's my notation. Now let's look at this next example. So you could pause the video here and have a go at doing some of the steps yourself if you wanted to, or you can just watch me go through it and then see if you can figure out what to do as I do it. So first thing, let's solve it. So we're looking for two numbers that add to give me 10 and multiply to 16. Nice easy one here. We're saying it's going to be 8 and 2. So we're saying x plus 8, x plus 2 is less than 0. So therefore we're saying x plus 8, 0, or x plus 2, 0. So x is equal to minus 8, or x is equal to minus 2. And let's plot those 2 points there. So we've solved it. So we've got our roots. I know my y-intercept is at 16. And if I complete my turning point, just to make sure it's really accurate, so half your b value, so x plus 5, all squared, square it, turn it negative, 25 plus 16 will be less than 0. So that becomes x plus 5 all squared minus 25 plus 16 gives me minus 9 is greater than, is less than 0. So we're saying minus 5 minus 9 would be your turning point. So we can go down to that and put our points there. So from here, I can then, again, if I wanted to, just to make my curve a little bit better, that would be my mirror line. And I know that this green point up here is 2.5 squares away. So I've got to go 2.5 squares away the other side. So that's where my point would end up being. And then I can join that up with a smooth curve to create my quadratic graph. Again, as I said, it doesn't have to be perfect. It's just to give you the approximate location of exactly what we're talking about and what the graph looks like, so we know where to shade. So let's now choose this point again. Let's now choose this point again, which we know is 0, 0, and substitute it into this equation up here. So we're saying 0 squared plus 10 times 0 plus 16 is less than 0. So that gives me 0. 0 plus 16. Is 16 less than 0? No. So that now is not true. Okay, that doesn't work. So 16 is not less than 0, and therefore you cannot shade. So you do not shade that point, which means I have to now shade inside the parabola. So if it's not true, if it doesn't work for that point, you then make sure you don't shade that point. And in this case, me not shading that point means I'm shading inside the parabola. Okay, because if I was to shade outside, I'd end up shading over that point, and that point is not true, so it cannot be shaded. Okay, so because that point is not true, I have to shade inside the parabola, and therefore if we go back looking at what we said up here, because I've shaded inside the parabola, that's how I'm going to represent my answer. So I'm going to say the points I'm going to be looking at are -8 and -2 because they're my two roots. So I say -8 is less than x, which is less than -2. So can it be -8? No, it can't actually be -8 because it says -8 is less than number. So therefore I could choose -7, -6, -5, -4, -3. They are all my possible answers that I could put in order to make that true. So if you then started substituting those points in, it would then end up giving you an answer which will give you less than 0. If you substitute -8 or -2, it will give you an answer that will end up being greater than 0, so it would not be true. Okay, so because I've shaded inside the parabola there, that's why I've noted it in this way here, and that's how you would need to actually put your answer down. Okay, last one then I'm going to show you, a little bit harder because actually what we've got now is your x squared value is greater than 1, so it's a little bit harder to solve, but you can have a go at doing it again if you're happy with that concept of solving when x squared is greater than 1. And what I've basically done is I've done this example here where it's greater than 0, and then I've done this example here where it's less than 0, so you can see the two different ways that we can work. So if you want to pause the video and have a go, you can have a go. If not, watch me and I'm going to go through it now. So in order to solve it first, I've got to do my a value times my c value. So I'm just looking for two numbers that multiply to give me -20, but add to give me 1. So my two numbers are going to be going to be -4 and +5, because -4 plus 5 gives me 1. And I'm going to put 2x in both brackets. So this is my shortcut way of factorizing. And I'm going to choose which one of those divide. That divides by 2. Keep the first one as it is, 2x plus 5, and then x minus 2. Again, if you're not 100% sure on what I've done there, go back and watch the video on factorizing quadratics. Okay, so then I can say 2x plus 5 equals 0, or x minus 2 equals 0. So x is equal to -5 over 2, or x is equal to 2. So now what I've got, so this would give me -2.5. I've got my roots. So I can plot those 2 points now. So one of my roots is +2, which is there. And one of my roots is -2.5, which is there. My y-intercept is -10. So if I actually choose a scale here of -2, -4, -6, -8, -10, then I know that's going to be my y-intercept. And again, I could complete the square to find the exact turning point, but I know that my my graph is going to look approximately like this. Okay, so it doesn't have to be perfect, as I said in the previous ones, and we can leave our graph like that for now. I now choose this point. Okay, so this point here, 0, 0 again, and I substitute in 0 to this equation. So 2 times 0 squared plus 0 minus 10 is greater than 0. So that will give me 0. Is -10 greater than 0? No. Okay, -10 is not greater than 0. So therefore, this part cannot be shaded. Okay, so for me, what I now need to do is I now need to shade outside the parabola, because -10 is not greater than 0, and therefore that point cannot be shaded. Okay, so cannot be shaded, which means for this left-hand question, remembering that that point there is -2.5 and this point here is 2, I would write my answer, because I've shaded outside the parabola, I would say x is less than -2.5, so it has to be that side of 2.5, and x is greater than 2. So I'd say or x is greater than 2. In order for that to work, in order for that to give me an answer which would be greater than 0, I cannot choose minus 2.5. It would have to be less than 2.5. Cannot choose 2. It'd have to be greater than 2. So that would be my answer for that question there. Let's now look at this one on the right hand side then. So go through the same process. I know that my roots would be exactly the same. So the roots would be minus 2.5 and 2. So the two roots are exactly the same and the graph is exactly the same. So what I've drawn here is exactly the same as this. But now I'm going to choose this point and notice the difference here. That is less than 0. That one's greater than 0. So when we look at this, when I substitute this purple point in and I say 2 times 0 squared plus 0 minus 10 is less than 0. Well, that gives me 0. Is minus 10 less than 0? Yes. Which means I must shade. So in this next example here, I must shade it. So that point here must be shaded, which means I would now shade inside the parabola. And my answer would then be represented as minus 2.5 is less than x, which is less than 2. And that would be my answer for solving that second example there. So you can see the real clear difference between where we shade based on what the inequality represents. Okay, so complex topic, difficult to get your head around, worth going back over anything you're not 100% sure on, but that is how you would solve quadratic inequalities and ensuring that you were using the correct notation, either that one or this one here on the right hand side, to make sure you get your answer correct. Okay, as I say, if there's bits on there that you're not 100% sure on, follow those links that I've put in the video just to go back and double check your knowledge on those skills you need. Hope you found it useful, hope it's helpful to you, and I will see you all in the next video.